Welcome again, Wildcats. All right, so today we're looking at Monday, January 9th, and we're looking at quadratic, formula, and the discriminant, and that's going to be on page 42. So if you would, update your table of contents. All right, now that your table of contents are updated, let's look at our notes. All right, so today we're going to solve quadratic functions, okay? And
Chromebooks have advanced our academic success. Some of our students have visited other school districts to share that success and have even spoke before the state legislature about the importance of technology in education. The proposed A through F system can't grade that.
That's right. You tell them, Temple High School. All right, so we're going to continue to utilize our Chromebook here. And so back to where we were. To solve a quadratic function, the function is set equal to 0. Okay? The solutions to a quadratic function are the x-intercepts, also called the roots and zeros. There are 3 types of solutions to a quadratic function. When the quadratic function intersects the x-axis twice, you have 2 solutions. When it touches the x-axis once, it's 1 real solution. And when it doesn't touch the x-axis or cross, there are no real solutions, also known as a complex number or imaginary solutions. Now, there are 3 ways to solve a quadratic function. Number 1, you can factor, which we've been doing. We've been factoring. Number 2, you complete the square, which we've done. Now, the new one today is the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times ac divided by 2a. Now, you're probably wondering, well, where in the world do those a, b's, and c's come from? Well, a quadratic function, and we can go, let's go all the way to the top. Quadratic function is f of x equals ax squared plus bx plus c. So that's where the a, b, and c come from, okay? All right. Now, this underneath the square root is called the discriminant. Now, the reason why the discriminant is important is because it tells you what types of solutions. So, when the discriminant, which means the value underneath the square root, is greater than 0, there's 2 real solutions. When the number underneath the square root, the discriminant, is equal to 0, it's 1 real solution. And when this number underneath the square root, known as the discriminant, is less than 0, there are no real solutions. Now, once you've found your solution, there are 2 ways to check the solution. You can check by graphing. So when you graph it, you can see, okay, these are where the solutions are. Or you can check the table. All right, so if you would, finish up your notes. All right, now that your notes are finished, let's look at the examples. Now remember, all these notes and examples are on page 42. So let's look at example number 1. Now the instructions say, find the zeros of each function using the quadratic formula. Okay? So when you solve using the quadratic formula, first we know that the number in front of x squared is 1. You need to know what a, b, and c are. So a equals 1, b equals 10, and c equals negative 2. Now looking back at my notes at the quadratic formula, we just basically plug those numbers in. So x equals negative b value, so negative 10, plus or minus the square root, and let me get a ruler so I can draw that little square root straight. Alright, got the ruler. Alright. So then it's b squared, so that's 10 squared minus 4, a is 1, c is negative 2. divided by 2, and then A is 1. By the way, if you're watching this, let me just give a shout out to the Flexi Ruler. They're flexible. You can see what you can go, right? And they're actually blue, Wildcat blue, and they're perfect rulers. It's the only ruler I use, okay? So if you don't have one, go to H-E-B and get yourself a Flexi Ruler. All right, so now X equals, -10 plus or minus the square root All right, and so you can use a calculator, but I think we can do this. 10 squared is 100, and then -4 times the -2 is a +8, so that's 108. Divided by 2. And so then you get X equals -10 plus or minus the square root. I don't believe the square root of 108 is a perfect root, so we're just going to leave it as this. All right, so example number 2. All right, so first things first, let's try this to be new. If you're following along examples, why not pause the video? I don't know what the pause button is. Press the pause button, okay? And then try example 2. Once you've got it all worked out, then click play and check if you're correct, okay? So go ahead and try that out. So go ahead and pause the video. All right, now I assume you've paused the video. So let's look at example 2 and you can check to see if your work is correct. So first things first, A equals 2, B equals, if there's not a number in front of X, put a 1, and C equals -10. Next thing, you just use the formula. So X equals -B, which is -1, plus or minus the square root of 1 squared minus 4 times 2 times -10 divided by 2 times 2. All right, so then X equals -1 plus or minus the square root All right, so then let's see. 1 squared is 1. -4 times 2 is -8. Times -10 is a +80. So 80 plus 1 is 81. Divided by 4. Now, because this is going to work out to be the square root of 81, I believe, is 9, we're going to actually separate our answers like this. So X equals -1 plus the square root of 81 is 9 divided by 4. And X equals -1 minus 9 divided by 4. So -1 plus 9 is 8. 8 divided by 4 is 2. So one of your solutions is 2. Now, -1 minus 9 is -10 divided by 4 is -10 divided by 4, which I believe reduces to be -5 divided by 2. All right, so there are 2 examples to get you kind of started on Monday's lesson. So if you feel comfortable with that, go ahead and work the other examples. And honestly, I think this is a pretty straightforward concept. You can probably finish this assignment maybe before in the class. Okay, so with that, have a wildcat emoji of a day.